Hello guys, welcome back. Today we're going to talk about Lambda expressions and functional interface in Java. So this concept has been introduced in Java 8. This is a game changer. Um, so this concept is not something new. This has been there in other languages for a while. For example, JavaScript, Python, and there are other Lisp. There are other functional programming languages. This is a very basic concept in those languages. So Java didn't have this concept, which is why basically like Java was not a functional programming language. It was purely object-oriented programming language. But to catch up with the industry and other languages, for example, Scala, when Scala came over, it supported both object-oriented and the functional programming aspect of it. So Java didn't have options, so it has to catch up with that concept to support across the industry. So they introduced this Lambda concept in Java 8. So this concept is kind of there, but it was not purely in the functional aspect. So what I mean, it was there, meaning that if you know in Java, we used to have these inner classes or anonymous classes, right? So let's say if you have interface with the one abstract method, and how do you implement that usually? So you will write a class, and then you'll write a class and implements that interface and implement that method, right? uh, in the other way, like there is an alternate way of defining that, right? So without defining a class, you directly write this anonymous class implementation. So what does it look like? I'll show you in a bit practically. But that is the same concept that they used as a foundational element for lambdas. How we can provide the body for the function. So I can show you that in a bit. So basically, like to summarize, we'll talk about lambda expressions and functional interface. Let's get to the concept. So let's take an example of some list of elements that you have. So let's say we have list of integers, and then we want to find out whether a given element is even or odd number, right? So usually, how do we do that? We loop through the elements, and then we check for every element if it is even or odd, right? Let's see what it look like in the coding. And then first we write that in the form of in the regular imperative style of programming, and then we convert that using lambdas and more functional manner, right? In this process you will come across what is lambda and what is functional interface, right? So let's define list of integers, right? Let's import that, and list equal to, let's say, arrays dot as list 1 2 3 4 5, right? We define the list of integers. Then usually how do we loop through? Let's say for loop, and then you'll say integer n, and then you provide list, and here the logic you would say n percentage 2 equal to 0. Then basically let's print out even here, else it is called odd, right? Simple program, right? What I believe is anytime you learn concepts, let's focus on simple examples so you can completely understand the concept. Then you can apply that concept anywhere you want with confidence, right? With utter clarity. So now let's run this program. What would you expect? It will print out odd even odd even odd even, which is good, right? So let's say, I mean, this may become cumbersome, right? Like if you start writing program like this, it end up a lot of lines of code and it's not easy to read. So let's say I want to move this into a separate function, and then I can call this function here, right? Let's define some interface. Can let's call it as calculate interface dot java, and then let's call this as interface, and then let's define some abstract method here. Let's say that method is gonna return string, and then it will determine whether given number is even or odd, right? So it takes integer number, right? So that is the interface with the abstract method, and I want to pass this logic to that function body. So one way is we can write a new class and then implement this interface, implement that method there with this logic. To save time, let's use anonymous class concept, so we can directly write that interface here and then implement the body. Then let's implement that body here, right? So is even, let's put this logic into that method, and here we will return this. So basically, since that method is gonna return, let's make sure we are returning it here, right? Odd. So cool. And here let's call that is even method and then pass this, right? Since that is returning whether it is even or odd, let's store that value into a variable, and then let's print out that result here. So output, it doesn't change, it's the same logic. I just moved that into some interface method implementation, right? Let's run that. So still the same output, right? What is the difference before to the previous program? We took this logic and put this into other interface method. So wherever you want to compute this even or odd, we can pass this instance variable, and then that callers can just call in.isEven, right? There is nothing new here. It is basically Java 7 pre-Java 8 version way of writing these programs, right? So here, if you look into, we are kind of creating this class and implementation, and then we are overriding the body, overriding this method with this body. All we are doing here, all this stuff we are doing just to provide this function body here, right? So is there a way that we could simplify this? Just provide the body and it should take care of rest of the stuff. That's where the lambdas comes into picture. So lambda is nothing but a simple function body. Okay, so it is a simple expression where you are providing a body to a function, right? So that you can use that function later for later use. So what I mean by that is, in this case, let's say calculate in equal to, I'm writing in the form of lambda. Okay, so lambda, like I said, it is just a function body. So what this function here, it takes some argument, input argument, you put arrow mark and you provide the body there. What is our body? This is our body. That's it. Let's comment out that and put that here. That's it. See how simple it is compared to this verbose way of defining anonymous class. So this part here is called lambda expression. It is a function body. So what Java does here, by looking at this logic, okay, so you are providing the body and then we are assigning that to a variable of type calculate interface. So then it goes look into calculate interface. Okay, oh, it has one method, and Java thinks that okay, so you want to connect this body to this function, right? That's what it does. Okay, you might get a question. So first let's run this program and you would still see the same output. Here nothing changed, right? Let's run that. Same output, right? Okay, so you might get a question. So currently it has only one method, right? What if I add one more method with just different name, right? Name, and then it also takes argument n. Two methods of same signature. Now how does this know, how does Java know that for which method this body belongs to, right? You can see right away it is complaining about that. Hey, the function body that you're trying to attach to, you're saying to attach to method in the calculate interface, but I find there are two methods. I don't know which method you are asking to attach to. So it is saying the target type of this expression must be a functional interface. That's what it's saying. If you want to attach this expression to some target, the target type must be a functional interface. What is functional interface? An interface which has only one abstract method. It should have only one abstract method. Then by default what it does is, when you write this kind of syntax lambda expressions, it automatically attaches to that one abstract method. So that's why it's working now, right? So now the error is gone. So what we can do is, we can also define this explicitly. We can annotate this class as a functional interface, so that by mistake one of your team members or anybody in a bigger company will come here and write one more method, right? So what we can do here, we can define this as a functional interface. Somebody looking at this class, oh, this class is functional interface, so I should not add any more methods here, right? So if somebody tries to write methods here, then compiler will immediately complain about it. See, hey, invalid functional interface annotation. Calculate interface is not a functional interface, right? And you're already seeing that because we put the one more method there. Here it is again complaining about it. So let's take that method away. So this is what the concept about lambda expression and the functional interface. So let's quickly write this for loop in the form of functional manner. So if you're not very familiar with the functional programming, that's fine. I will go through that in depth in the other videos. But for simplicity, like for this simple problem, how we can utilize this lambda expression and write this in the form of functional manner, right? So we have list, right? And then we can get a stream, and then we map on each element. So map takes function again. So in this case, what function we want to apply this on this element? This is the function we want to apply, right? So we will use method reference here, and then we will call isEven. So this method reference is a wonderful concept which will make a program concise and more easier with a few lines of code. What it does is, it map on every element. On every element, it's going to call this method, and it automatically pass that element as an argument to this method, right? And then when you write map, you need to collect all the elements eventually using collectors. So this is all Java 8 APIs. Collectors dot to list. So we're collecting the list here. What is that list? So what this function does, it takes every element and returns even or odd, right? So this method is called on every element. So what, in a functional way, what is that? How do you put that in words? Is that, hey, you have list of elements. You please apply this function on every element. That's how you say in functional programming. In object-oriented programming, how do you say it? Hey, you have object, and then you have methods in the object, and you will say, hey, call that object, right? Object dot method, object dot, right? That is an imperative object-oriented style. In the functional programming, you always refer to the functions, and then you will say apply those functions. Apply. You're writing a function, you define the function already, and you're using it for later, right? When you're using it, what that means is you're applying that function to those elements, or it can be anywhere, right? What, in a simple manner, like, what is functional programming? Functional programming is all about composing functions and writing programs, right? You're writing programs by composing functions together, which means you can pass functions as an arguments to other functions, right? It's all about functions. So in this case, see, you are already passing function as an argument to other function here, which is a simple example. And collect that here, collect the list, and then this is basically the result, right? And if you, so basically that is an array. What would you expect? You would expect array of odd even, right? Let's print out that. Result clear, and then run that. See, this is array, that is the result. So the previous output is this one. Let's comment out that, and let's rerun that again. I mean, you got the concept, right? So now this is the output that we got. So yeah, so that's all, guys, for today. Just to summarize, we talked about lambda expressions. Lambda expression is about a functional body that you define, and then you use that for later, right? It is a simple implementation to a function, and once you define that, you can pass that as a argument to the other functions, and you can apply that wherever it is applicable, right? And this lambda concept is possible on the basis of functional interfaces, right? In Java, you have, for example, you can take an example of a runnable class which implements thread, right? So you can also implement threads in the sense, in the concept of thread, you would use runnable, right? Which implements the run method. So there you can simply write new runnable run method, so you can use lambda concept there as well. But yeah, you got the concept, right? Functional interface, it's a one abstract method. Using that, you define lambda expressions, right? All right, we'll catch up with a new concept in the next video. Until then, see you guys, bye.